Okay, let's look at imaginary numbers. So there is a definition where there's a number called I, which is defined as the square root of -1. Now if we squared both sides of that equation, we would get that I squared is equal to -1. Okay, and this is called the imaginary number. Okay, so that is a definition. So when we look at simplifying something like the square root of -48, we can rewrite that as -1, and then 16 times 3 is 48, so I'm going to rewrite that 48 as 16 times 3. And then I can take the square root of each of those separately. So the square root of -1 is defined as I. The square root of 16 is 4, and the square root of 3 doesn't simplify anymore. And I like to write that with the I right in front of the radical. For me, that's just easy to see. It's also correct to write the number 4 square root of 3 and then put the I out in the back. But for me, write a little messy, and sometimes it's hard to tell where my square root ends. So for me personally, this is how I would write it. Now, when we're multiplying with negatives inside the radical, we need to be really careful, because square root of 16, that simplifies to square root of -1 times the square root of 16. And then the square root of 18, we can write that as square root of -1, and then 18, we could write that as 9 times 2. Then when we start simplifying, we've got square root of -1 is I, square root of 16 is 4, times another square root of -1 is another I, square root of 9 is 3, and then the square root of 2 doesn't simplify anymore. Okay, and I'm going to multiply my numbers. 4 times 3 is 12, and then I times I, that is I squared, and we have this definition. I squared is defined as -1, so it would be 12 times -1, which is -12 times the square root of 2. Alright, let's do this next one. We just figured out what the square root of -48 was over here. So that is 4i times the square root of 3. And then the square root of -3 would be square root of -1 times the square root of 3. So that would be I times the square root of 3. And now we do get a little canceling. Anything divided by itself is just 1, including I divided by I. That's +1. So this does simplify to 4. So when you're dividing, you actually do get to cancel out those i's, but if you have I times I, that's where we go back to this definition that I squared is -1. Okay, so I divided by I, that is a +1. And I times I is a -1. Great. Okay, so now we can look at something called complex numbers. And a complex number has both a real number and an imaginary component, both of those. So if you look at just the plain number 4, that actually has 0 imaginary numbers, so that would be the standard form of that number right there, okay? So we need a real component and an imaginary component. Now, if we have it looking like a big fraction, what we want to do is just divide both parts of the numerator by that 10 and then simplify. Okay, so our real component is -2 divided by 10, so that simplifies to -1/5. And then here, square root of -8, well, square root of -8 would be -1 times 4 times 2. So that square root of -8 simplifies to, square root of 4 is 2, square root of -1 is I, square root of 2 just simplifies to square root of 2. It doesn't go any further. And now I can simplify the 2 and the 10, giving a final answer here of -1/5 plus, let's see, 2 and 10, that simplifies to 1/5. So it would be 1 times I times square root of 2 all over 5. And that is the standard form. So we've got a real component and an imaginary component right there. And sometimes that's written where you've got the number part and then all of that's times I out in the front. So either one is fine. Both of those mean the same thing. Okay, next I'm going to look at what happens when we take powers of I. We'll deal with multiplying complex numbers in a minute and taking powers of complex numbers, but let's just look at what happens with I. All right, we have the definition that I squared is -1. So I cubed would be I squared times another I, that's I cubed. So I squared was already -1, and then times I gives me that I cubed is -I. All right, and then just keep going. I to the fourth, well, that's I cubed times another I, and I cubed I found out was -I times another I would be -I squared, and I have the definition of I squared, that is -1. So I to the fourth is -1 times -1 is +1. All right, so we can also look at this a little bit differently, like rotations. If I start with the number 1 and multiply it times I've got I, and then I multiply that times another I, that would be I squared, which is -1. And then I multiply I squared by another I, that would be I cubed, which we found was -1. And then multiply by another I, which would be I to the fourth, which is 1. So we can look at multiplying by I as a 90-degree rotation. All right, let's look at what happens when you keep rotating. All right, so we got to I to the fourth, and if we went again around another time, I to the fifth is the same thing as I, multiplying by another I, so I to the sixth, that would bring me over to -1. I to the seventh brings me to -I, and then rotating, multiplying by yet one more I gives me I to the eighth, which is 1. All right, we can just keep on going. If we multiply by another I, we'd have I to the ninth, which brings us to I. Go around again, I to the 10th equals -1, I to the 11th. We're just keeping rotating around. And I to the 12th is 1. Okay, notice that I to the 4th is 1. I to the 8th is 1. I to the 12th is 1. Any exponent that's a multiple of 4 is equal to 1. I'm going to write that down. So I to the 4th is 1. I to the 8th is 1. I to the 12th is 1. That would, the next multiple of 4 would be the 16th, the 20th. Okay, so that's going to be a really useful way of dealing with powers of I. Okay, great. So now let's try a few of these problems. All right, so I to the 9th, that one we just did right here, and we got that that is equal to I. Now I can think of that as a power of, with the exponent that's a multiple of 4. So another way of looking at that, instead of just rotating 9 times, you could also look at I to the 9th, that's the same thing as I to the 8th times another I, right? We can't change how many I's we start with. We started with 9, but rewriting that as I to the 8th times I might be a nice pattern, you know, it might be just a nice shortcut. I to the 8th, any exponent who's a multiple of 4 is just 1, and then times I gives us that final answer of I. And that is helpful, because I don't, with here this next one, I to the 19th, I don't really want to have to go around 19 times. I mean, I would get to the right answer. If you like that method, that's great. But another way of looking at that is rewrite I to the 19th. So I can rewrite that as I to the 16th times I cubed. Any exponent who's a multiple of 4 is just 1. And then I cubed, we figured that one out. I cubed right down here is -I. So this simplifies to -I. And I've had some students look at it also as, well, hey, I to the 20th, that would be 1, but I'm not quite to 20, I'm 1 rotation back, so I would be at negative I, so that's another pattern you can think about. All right, let's look at I to the negative 31. Well, if I look at that as negative 32 and then times a I to the 1, when I add exponents here, I do indeed get that negative 31, okay? Any exponent who is a multiple of 4 is just 1 because I to the negative 32 is the same thing as I to the 4th to the negative 8th. I to the 4th is 1. 1 to the negative 8th, that's 1 over 1 to the 8th, that's still just 1. So that becomes 1 times I, which is I. Phew, all right. Okay, so the big idea is rewrite your problem so that you have an exponent who is a multiple of 4. That any exponent who is a multiple of 4, positive or negative, simplifies to 1. And then you basically can just look at what was the remainder here. And that is one way of looking at these. If that's confusing, just rotate. Negative rotations would just rotate clockwise. It just rotates the other direction.